Hi, I'm Jinghui Cheng from Polytechnique Montreal, and I'm presenting our work exploring the use of style-based generative machine learning techniques in supporting inspiration in the creative design practice of graphical user interfaces. This work is done with my students Mohammad, Amin, Mozaffari, and Xinyuan Zhang from Polytechnique Montreal, and my collaborator Jing Guo from McGill University. In the design process of graphical user interfaces, inspiration from existing design examples plays an important role. Designers often actively seek, combine, and transform design examples to draw an analogy from other products and resources to inform the design task at hand. Currently, designers mainly rely on two types of approaches when seeking inspirational resources. Both have important limitations. First, the proliferating design gallery platforms, such as Dribbble and Behance, support a bottom-up, serendipitous inspirational process. These galleries contain collections of design examples in various application domains, with drastically different design styles. Designers would examine these collections, seemingly without a goal, in order to find interesting examples helpful to their work. However, this is sometimes an overwhelming experience if the designer have concrete constraints and purposes in their work, resulting in distraction or drift in their design focus. Second, some recent work has proposed design inspirational tools that suggest examples based on preliminary design input. These techniques usually leverage image similarity assessment algorithms to retrieve examples that are similar to the input image. While they provide a way of supporting a top-down, targeted inspirational process, overexposure to examples with similar styles might cause design fixation that hinders the creativity of the designers. To address these problems, we aimed at exploring techniques that find a balance between serendipitous and targeted inspiration in the user interface design process. We proposed GANSpiration. This approach first takes a preliminary user interface design mockup as an input, then transforms it into a vector representation called latent code. The style of the original input is then merged using a style-based generative machine learning technique called StyleGAN with a set of target latent codes to synthesize new examples. These target latent codes can be randomly selected or generated, or alternatively, they can come from manually chosen design artifacts that represent a desired style. In the style merging process, the styles of different resolution levels of the target image are used to replace that of the source image, so that the style of the source image can be influenced by the target image at different granularity levels. This is an important and interesting advantage provided by the StyleGAN method. While StyleGAN is intuitively promising, several challenges need to be taken up before it can be adapted to support the designer's workflow. First of all, we have to train StyleGAN with a dataset of UI images. We used a cleaned-up version of a graphical user interface dataset called Recall to train StyleGAN. The details of the dataset and the training process are described in our paper. Additionally, during the style merge process, we exhausted all the resolution combinations of the source and target images. This results in a large number of generated images. Some of them can be similar or repetitive. To reselect the most distinguishable examples for the designers, we then used a clustering method to find the representative examples among all the initial outputs. Furthermore, the generated UI images might lose certain realistic details that might be important for designers' work at hand. GANSpiration therefore can be configured to use the generated UI images to search real UI screenshots for inspiration. To evaluate the performance and the potential usefulness of the GANSpiration-based techniques, we conducted a quantitative evaluation study and a user study. Both of the studies relied on the scenario where a designer has a preliminary design at hand. They will then feed the preliminary design in the system to get a set of design images as outputs for inspiration to improve the original design. The quantitative study indicates the potential of GANSpiration-based methods in balancing targeted and serendipitous inspiration. We found that the outputs provided by our methods have resulted in significantly lower similarity to the input image, and significantly higher diversity among the outputs themselves than the similarity search baseline. At the same time, our methods resulted in significantly higher similarity, thus relevance, than random examples. A user evaluation with 5 UI/UX professionals demonstrated how well the results of GANSpiration may help in their design practice. Overall, the participants considered the GANSpiration-based approaches as viable ways to gain inspiration in their practical design workflows, providing both diverse and relevant design examples. They observed that the directly generated images provided enough abstraction and omitted unnecessary details to convey the design concepts, similar to the effect of using low-fidelity prototypes. However, they considered more inspirational value in full-fledged UI design screenshots. Particularly, they appreciated the fact that the examples suggested provided ideas on the level of both overall UI structure and the specific components. Much more detail of our study design and the results can be found in our paper. Together, our results provided several implications to the design of tools that leverage generative techniques for design inspiration. I will describe two of the implications here. First, our studies revealed that the style-based image generation techniques can provide inspiration at different granularity levels. Thus, tools for design inspiration have the opportunity to directly incorporate these levels through explaining the intention of the suggested examples or allowing designers to directly manipulate these granularity levels. Second, visual quality is an important factor to consider for inspiration. On one hand, blurry images may provide inspirational support similar to low-fidelity prototypes. On the other hand, our participants seem to prefer full-fledged UI screenshots since they may provide component-level ideas. Thus, tools for design inspiration need to consider the benefits and drawbacks related to the visual quality of design examples, providing alternatives that support different inspirational purposes. Overall, our work demonstrates the potential of applying style-based generative machine learning techniques in a challenging context of design inspiration and creativity support. We hope it will inspire and pave the road for future efforts in this line of work. Thank you so much for your attention. Please read our paper for details and contact us if you have any questions or comments.